Hello everyone. Today we are going to see class 8 science chapter number 3. The name of the chapter is a force and pressure. In this we are going to learn about force, different equations related with the force and the motion, and we are going to learn about pressure. First of all, when we talk about the force, for that, we should know about Newton's first law of motion. Because Newton's first law of motion, what it states that a stationary object remains in the state of a rest, or the moving object remains to or continues to move with the same speed and direction when no force is acting on the object. In a simple words, if we want to understand it, let's take an example. If there is a table and a book is kept on it, this book will remain this book will remain on the table in a stationary state unless and until there is an external force acting on it. Once we try to push it, then what will happen? The book will start to move. Or if we want to lift it upward, we have to take our hand up to the book, we have to pick it, and then we have to move the book. If we are not applying these forces, if I am not applying this force, then what will happen? The book will remain at the same place. This is the first part of it. Another part is what? If one of the ball is moving, it will continues in the same direction. It will continue in the same direction unless someone is hitting it in between. If I am hitting it in between, what will happen? The direction will change. So Newton's first law states that only, it's given over here, stationary object on which no force is acting remains stationary. An object in motion continues to move with the same speed and direction when no force is acting on the object. This is Newton's first law. Okay. Same way, when we talk about the motion, the word motion, that is possible only if there is an external unbalanced force acting on it. When we talk about the unbalanced force or the force acting on the object, means what? If we have one of the object and I want to move it, I have to apply a force on it. Like example, they have taken over here the first example of a car pushed by a man. If we want to move the car, then we have to push it. The person is pushing it. Here, the dog is pulled by the boy. Force is applied. Football is kicked by a footballer or the boy. So all this forces what we have is nothing but what a one special category we have having, and that special category is nothing but what the contact forces. Contact forces means if we want to move something, we want to pick up something, then the there is a point of contact. Point of contact, like here, this is a point of contact where the person is pushing the car. Here, the point of contact is this, the boy is pulling it. Point of contact when the leg hit the ball. So, these kind of a forces are like contact forces, where there is a point of contact or a common point between the force applier, means who is applying a force, and the object on which force is applied. Another type we have, that is the non-contact forces. Example, suppose if you have a ball and you are throwing it upward towards sky, what will happen? Suppose if there is a one ball and someone is throwing it upward, what will happen? This ball will go up to a certain height, and again from there it will start coming downward. Till it's going upward, it's okay, but when it reaches at the top spot or the top position, after that, what happened? It comes downward. Automatically, it comes downward. So there is a non-contact force between the Earth's surface and the ball. There is no contact between the ball and the Earth, but still, Earth is pulling it downward. The another example they have taken over here is of the coconut tree. They have taken an example of a coconut tree. You can see here the coconut is falling from top towards Earth's surface. Why this is happening? The non-contact force between Earth and that coconut. Same way, if there is an iron nail kept and the magnet is brought near to it, what happens? Iron nail moves towards the magnet. There is no contact between the iron nail and the magnet, but still the iron nail gets attracted towards magnet. And that is why it's just because of the magnetic force of the magnet. And the force comes under the category of the non-contact forces. Same way, there the one another example they have taken of the electrostatic force of attraction. What you are supposed to do? Dry hair, just comb it with the comb and bring it near to the small pieces, the bits of a papers which we call the small pieces of a paper. Bring that combed comb near to that particular pieces. What will happen? The small paper pieces will be attracted towards the comb. So that is also one example of the non-contact force. And here you can see this particular force comes under the category of the electrostatic force. The coconut tree which we have discussed, that is gravitational force, and the magnet is magnetic force. So these are the examples for the non-contact forces. Further, if you will see in this particular part, if you will see the another example they have taken of this particular non-contact force to explain the non-contact force. What they did, they have taken a one tray-like structure. They filled it with the water, the half they filled with the water, and the two exactly same bottles. The cap is on, means air we have to fill inside, and we have to just put the cap and just keep inside the water and then place a two magnet at the top of it. Now this two magnet, if there is a north and south pole facing each other, then what will happen? The bottles will move towards each other. If it's not the situation, if we are having two similar poles, north and north or south and south, then what will happen? They will repel each other. Now here they are not in contact, but still they will repel or they will attract according to the position of the magnet's poles. So this is also one example or the demonstration for the non-contact forces. Further, we have to go towards the balanced and unbalanced force. Balanced and unbalanced force. Whenever particular object is in a stationary state. Stationary means rest, not moving. That is the meaning of a stationary state. If one particular object is at stationary state, it means that there is a balanced force acting on it. Balanced force means what? If any object is kept, like if I am taking the example of a table and the book is kept on it, so there is a force of gravity which is pulling it downward, and at the same time the table is applying a force upward. So due to that, what happened? There is a balance. If I am taking this as a F1 and F2, then F1 is equal to F2 with a negative sign. What does it mean? It means that both the forces, which is downward and which is upward, is balanced. They are balancing each other, and that's why the particular book is not moving. Simply, on the other side, if the object is moving, it means there is an unbalanced force acting on it. Here they have taken this example, this particular example they have taken. This, if I want to draw it from the other angle, and one of the object is kept and the two forces are applied by putting certain weights in the pan. If there is a certain weight, let M1 and M2. So in this particular case, if M1 is greater than M2, if M1 is greater than M2 or M2 is greater than M1, what will happen in this case? There will be a unbalanced force acting on this particular object, and due to that it will start moving with the left or right. It depends which mass is more. But suppose if I am having M1 is equal to M2. So in this particular case, what will happen? Both the forces will be equal and it will remain at the center. And this category will be called as a balanced force situation, and this too will be called as a non-balanced forces. Okay. Further is when we talk about this particular section, they have given if more than one force are acting on a body, then the effect on the body is due to the net force. Net force means overall all the forces, whatever is working or on the particular object, the net of that will be the direction of that particular object. If all the forces are getting balanced, then it will be at the stationary state. If it is not getting balanced, then object will come into the motion.